Hello everyone, this is North America Math Contest Go Go Go. This week we are going to discuss about another math problem. So an arithmetic sequence, everyone knows what an arithmetic sequence if they take Canadian Senior Mathematics Contest. A geometric sequence, okay, everyone will also know what a geometric sequence is if they take the Canadian Senior Mathematics Contest. Okay, so let's see the problem. Determine a real number W such that this, and this is an arithmetic sequence. Using the basic theorem of arithmetic, we can get this. 2 minus 3, which is this. Make it opposite. 2 minus 1. It will be easier. A plus 2r minus a plus r is equals to this. So this means that this is equals to a since it belongs to the first term. And then we can just calculate this is equals to this. Which is equivalent to 2 over 3. And this is equals to this. So we can get W is equals to this. Nice. Based on my checking, I get problem 1 right. Let's see the second problem. It is another arithmetic sequence problem. So now let's talk about problem 2. Problem 2 states that suppose y1z is a geometric sequence with y and z both positive. Determine all real number x such as this and this are an arithmetic sequence for all y and z. So it is getting a bit complicated here. So we want y1z to be, since we want it to be an arithmetic sequence, we can get that this is equals to a plus r, a plus 2r. So which is 2x is equals to this plus this. Because a plus r is equals to a first term plus the third term divided by 2. So after we draw this conclusion, we can then go forward. So let's see the first criteria. y1z is a geometric sequence, right? So this means y is equals to a, 1 is equals to ar, and z is equals to ar squared. So we can time 1 and yz is equals to ar is equals to a square r square. So the root of yz is the second term. It's the second term. The root of the first term and the third term. So after that, since we know that this is 1, and we can get that yz is also equivalent to 1. So this means we can then draw a conclusion that it should look like this. So to solve this, we time this size by y. Not time, I mean time the both parts of it by y. So it should be like this. So we can get that this equation is equivalent to 1. So therefore, we can draw equivalent that this is equals to 1 divided by 2. So this means we can conclude that 1x is 1 divided by 2. Why? This forms an arithmetic sequence. Now let's talk about the third problem we are facing. So this problem is, suppose that A, B, C, D is a geometric sequence, and this is an arithmetic sequence. So this means that A is equals to A, B is equals to AR, C is equals to AR squared, D is equals to AR cubed. So this means we can get that this, and this forms a arithmetic sequence. Or let's use another way to express them, which is this, this, and this forms an arithmetic sequence. So this means that we can just directly draw a conclusion that this is equals to an arithmetic sequence, since it must be. Okay, so we get to that step. Using equation 1, we can get equation 2. And we can get this one also. So this means we can then draw a conclusion that A is equal to this, plus 2 r squared minus r cubed. Then we can draw a conclusion that r squared is equal to r3. Let's redo it. This minus this, we get that this has an r. Has a plus r, and then it has a plus 1. So we get negative r squared plus r plus 1, which is equivalent to this. So we have one solution at r is equal to 1. Then we determine the other two solution, which is, if you have calculator, you can just call it out easily. It is this. Let's see, we want A and B, D, both positive. Root 5 divided by 2. And what are we required to get? We are required to determine all the possible values. So let's then talk about why 1 is not okay. So if 1 is okay, then B is equal to A and D is equal to A and A is equal to A, which contradicts with what the problem asks us. Then we can see it asks us determine all the possible values of B divided by A. So B is AR and A is A, so we can get that it is R. So therefore the only possible value is 1 plus root 5 divided by 2. And here we come to the end of this chapter, and I hope you have learned a lot. See you next week. Bye!